Hi everyone, welcome to your PlayPosit for our short week. I hope that you all had a great weekend and a great Monday. We had that long weekend, so hope you got in some relaxing. I know that we are excited because our house, well, myself and my daughter are officially um, recovered from COVID. My husband did test positive today, but thankfully he is on the more mild side. So things are definitely looking up here, and I'm excited to see you all this week. We're going to be covering 1.08 through 1.10. That's the end of Unit 1. So go ahead and grab your notes and we'll get started. Today we are going to be solving real world math problems. That's pretty much it. And it involves these standards. I try to list the standards for you just in case you ever want to go and do extra practice on that math website I have. You can look them up by standard. And this meme like never gets old. His face is on all kinds of memes. Just a reminder that we are using Desmos graphing calculator. It looks just like this. You want to make sure it's the green bar that says Virginia and it's the graphing calculator. Don't forget the graphing calculator does have the scientific calculator down here in the bottom. So I'll link this in our PlayPosit, but this is the one we want to use all year because this is the one you're going to see on the SOL. So first, let's do a quick flashback to some topics that we've already covered. And it wants us to tell them whether or not n equals 3 is a solution to this equation. So we've seen where we can actually do this a few different ways. For this one, I want to do substitution because we haven't really gotten into our solving equations unit yet. That's coming next. Although you probably know how to solve this by solving for n, what we're going to do is we're going to plug in 3 everywhere we see an n and see whether it's true or false. Negative 63 divided by 3. Does that equal 21? Now we can grab our Desmos calculator and double check. We can also do this by hand. We know that 3 goes into 6 2 times and 3 goes into 3 1 time. It is a negative. So in fact, it does balance out. N equals 3 is a solution to this equation. All right, getting into our 1.08. This is the dimensional analysis unit. And I don't know about y'all, but I never really called it that before. I was a math teacher. This is more about converting, right? Conversions, but it's just another way to call it dimensional analysis. So it wants to know how many feet are in 120 inches. So whenever I do this, I usually like to start with what I know. I was trying to erase this before. I'll just scratch that out. Or what we're given. We're given 120 inches, right? And we know that we want feet to be our answer in the end. So we're going to multiply by feet over inches. And we want the feet on the top because that's what we want our solution to end up in. And you can see if we do it this way, the inches will cancel. And we know that there is 1 foot and 12 inches. So then we would just multiply 120 times 1. You could put this over 1 and you get 1 times 12. And remember, our inches canceled. And 120 divided by 12 is 10. And we have our feet left over, which is what we wanted. You may be able to do this one differently. You may be able to do mental math with this. You're like, I know that there are 12 inches in 1 foot and 120 divided by 12 is 10. That's totally fine. If you look at example 2, again, well, let's review. We know that there is 1 yard in 3 feet. We also know that there is 1 foot in 12 inches. So this information is going to be helpful to us. And we're going to, again, start with what we're given. We're given 9,540 inches, and we want to end up with yards. But we don't have a direct inches to yards conversion, right? We have inches to feet and feet to yards. So we can kind of use the transitive property here a little bit. We're trying, if we can get inches to feet, we can then go feet to yards. So let's first convert this inches amount to feet. And we're going to do that the same way. We're going to multiply by, now we want to get rid of inches, so that's going to go on the bottom. We want feet, so that's going to go on the top. And there is 1 foot and 12 inches. So our inches cancel, right? And we multiply across 9,540 feet over 12. And this is where I would grab my Desmos calculator. And we have, let's see, 950 divided by 12. 795. Okay, so there is 795 feet in 9,540 inches. Okay, now we can multiply by, we want to get to yards, so we want yards to be on the top, and we want to cancel out feet, so that's going to be on the bottom. And there is 1 yard in 3 feet. So we'll do the same thing. The feet will cancel, multiply across 795 feet divided by 3. Let's see what that is. Oh, my little box keeps popping up. 795 divided by 3, and you get 265 feet. And that is our answer. Whoops, hopefully you all caught that as well. Look, we want yards. I don't know why I said feet. I canceled the feet. Our answer is in yards. My apologies. I just wrote the wrong label. So yards is what we end up with on top. That's what our answer is in, and it is A. Example 3. Lynn feeds her cat 65 grams of cat food per day. So I might just start writing some. 65 grams per day. About how many ounces of cat food will she feed her cat in 5 weeks? 1 ounce is approximately 28.3 grams. Okay, so there's a couple ways we can do this problem. Kind of depends where your brain goes first. Mine went right here with this 5 weeks. So this is per day, but we want to know the total in 5 weeks. So there are 7 days in 1 week. So how many days are in 5 weeks? That would be 7 times 5, which is 35 days. So we're talking about 35 total days. And she feeds her cat 65 grams per day. So let's get the total grams. That would be 35 times 65. Let's see what that is. 35 times 65. 2,275 grams of cat food. But we don't want grams, we want ounces, and it says that 1 ounce is approximately 28.3 grams. So if this is the total grams and we know 1 ounce is this, all we have to do is divide by 28.3. Let's see what that is. 2275 divided by 28.3. 80.388. So it doesn't say what to round to. So let's just round, what do you think? 10th place. So 80.4 grams. So be careful with problems like this. You want to make sure you're taking into account the entire period, this 5 weeks here, and how many days that is. Example 4, there are 7 more dogs than cats in a kennel. We did this problem already. This is so funny. I want y'all to try this on your own. Check out the PlayPosit from last week. This is the same problem. So try this on your own without my help and see if you can get to the same answer. I'm going to pop up an interaction for you to solve it. So remember this example that we shared in our PlayPosit? It says Miss Winslow plays a babysitter 1 to 2 hours per week to watch her youngest daughter, Sophia, while she attends some meetings. The sitter, who is super qualified, charges a flat fee of $10 per month to help cover her CPR certification and $15 an hour. So this word flat fee is super important. A flat fee is something that's not going to change ever, really, unless she changes that flat fee. And the per hour will change, right, depending on how many hours she works. I mean, the fee per hour doesn't change, but her total compensation will change based on how many hours she works. So let's come up with a cost equation. We know that the flat fee is the plus 10. That's going to be our constant. It's not going to change based on her hours. And then the 15 we are going to multiply by, we could say H if you want, by the number of hours she works. Let's see, how much do I owe her if she watches Sophia for 4 hours in September? So that would be, we just have to multiply by 4. And this would be what, 60 plus 10, $70. That doesn't seem like very much for a whole month. How much do I owe her for 8 hours in October? So we would do the same thing, right? 15 times 8 plus 10. And what is 15 times 8? It's going to be double that, right? Let's just double check. Yeah, 120. So it's going to be $130. This might seem to you like, I don't know, not very helpful. Like, who is going to actually have a cost equation for their babysitter? Well, I did, but these cost equations live in all sorts of human resource programs already, and it helps calculate the amount of money an employee is paid based on the amount of hours they work. I used to work at the Gap when I was in high school, you know, the clothing store in the mall. I loved working there. And we actually had to punch our hours in a time clock, so that ages me a lot. And we had like a time card. And at the end of the week, our manager would take that time card and literally compute it in an equation like this. Now, since then, things have definitely, I mean, I'm not that old, but I don't believe there are punch cards anymore. I'm not sure. I don't work in an hourly field anymore, but that would be interesting to know if they still do the punch cards. But they're still built into the online programs that calculates the salary and pay for employees. So let's recall the parts of an expression now that we did it a little bit over here with the constant and the variable, right? So 6 here is going to be our constant. It never changes. And then how many terms does this expression have? It has 1, 2, 3, 4 terms. And we could say that the coefficient of the first term is 2, for example. So true or false? These are 4 different questions I'm going to ask you. Number 1, true or false? This expression has 4 terms. 1, 2, 3, 4. Remember, terms are separated by addition and subtraction. So this is true. Number 2, the coefficient of the third term is -6. Well, let's see, here's the first term, second term, third term, fourth term. Yep, the number in front of the third term's variable is -6. That is true. Number 3, the second term is a constant. Here's the second term. Nope, that's a variable. That's false. C is a variable. C is going to change depending on what the problem tells you C is, so that is false. And number 4, the third term is 6xy. Here's the third term. This is tricky. We want to include the sign there, so we were going to say that's false. It should be -6xy. So some examples where we're going to analyze the equations. Here they give us the expression. They give us an expression here, and it tells us it represents Javier's total cost in dollars for buying some postcards and a bottle of water at a souvenir shop. Which statement is correct? So Let's analyze this expression. What do we think the $1 is representing? Is it representing the cost of the postcard or the cost of the water? And what do we think the 225 is representing? The cost of the postcards or the cost of the water? So the clue words there I underlined. It says some postcards. Do we know how many postcards? No, we don't know how many. So this is our variable. And Javier bought a bottle of water. This indicates it's one bottle of water. So the cost of one bottle of water will be constant. It's not going to change. And that's $2.25. So the water is $2.25 and postcards are $1 each. So sometimes it's just reading the clues in the problem. Number 6, example 6. Here's our expression. And it tells us that's the balance in dollars of a bank account after X months. So X represents the months. It told us right there in the problem. What is the rate of change in dollars per month of the bank account balance? So something we haven't talked about explicitly yet, rate of change is another word for slope. Do y'all remember that from either Math 6, Math 7? Slope is the rate of change, the change in y over the change in x. And we're going to talk a lot more about that in the coming weeks. But this phrase here, rate of change, means slope in dollars per month. So this phrase here will help us as well, per month. Remember, x is months. It's -50 per month. So the rate of change is -50 per month. So what does that mean? Yikes. I mean, it's not terrible because we are getting $250, like, so I guess that's the where the bank account started. But yeah, it's down $50 a month because that negative there. And have to start contributing to that bank account. Example 7. Whoa. Has anyone ever been rock climbing? I have never done it in real life like this, and I also have never done it on like a climbing wall. I don't know if I have enough upper body strength. It takes a lot of strength. Maybe I'll try it one day. I'm curious if y'all have tried it. We can talk about it in class. All right, but this expression 2x plus 50 represents the elevation above sea level in meters of a rock climber after climbing X minutes. So X is the amount of minutes. That's our variable. That's what's going to change. What does the 2 represent? This climber is increasing 2 meters per minute if X is 1. It depending on what X is, right? What is the rock climber's initial height above sea level? Initial height. So it's where the climber started. Just like in that last problem, let me go back. The amount of money that the bank account started in was 250 because that's our constant. So here, they're going to start 50 feet or 50 meters above sea level. And then this number here is going to tell us what the climber does after X minutes. So that constant, that 50, is going to be the initial height. Example 8. Here's our expression. This models the amount of sales tax charged on a purchase that includes a percent discount and money off coupon, where X is the original price. So here's the original price. And we're talking about something we're going to take money off, and there's a percent discount. So this is like saying, you know, everything is 50% off, right? And then you get to the register and you also have a $5 off coupon. Most places don't let you use both at the same time, but it looks like this place is. That's nice. Match each part of the expression to the description that matches. All right, so use some clues in this problem to help us. Let's read through these. Sales tax rate. You'll remember from previous math courses, sales tax is always written as a percent that we have converted to a decimal. Remember, and you multiply it by the cost of the item. So if you're going to pay sales tax, you're going to pay sales tax on your entire purchase. So which decimal are we multiplying by everything? Let me rewrite this over here. There's two decimals in this problem, right? 0.07 and 0.9. We're multiplying the 0.07 by everything. So that is going to be our sales tax. We pay sales tax on the entire purchase. Here we have the money off coupon. That was one of our buzzwords up here. And we know money off is going to be a subtraction indicator, right? You're taking it off of the cost. And it's just money. It doesn't have to do with percents or decimals. I mean, I guess you could get like a 50-cent off coupon. But here, because we're talking about a percent discount and a money off, the money off is the $5. All right, cost after the percent discount is deducted from the original price. Now, I don't know about you guys, that one's like makes my brain go, what? Huh? So if that ever happens to you, let's go to the next one and see if we can process of elimination it. Total cost before sales tax is applied. So remember, our sales tax is this. So the total cost of the item before we do that is this whole thing. That's the total cost of the item before sales tax. So that's going to be this one. So this third one here is going to go to the 0.9 times x. And so that's describing the cost after just the percent discount. And that makes sense now that we can look at that, right? From the original price. And x is the original price, which we knew from the beginning. Original price. And the percent discount is 90%. That's a huge discount. Man, this person is not going to pay very much money for this item at all. All right, thanks for sticking with me. This unit was a lot about problem solving, using the clues in the problems to help indicate like an operation that was happening, right? We said things like money off, that indicates subtraction, and being able to identify the parts of those expressions, which we're going to build more off of in the coming units. I will see you all later this week.